Oh, hey, I'm doing some research on waterproofing, French drains, and insulation. So let's talk about it. Today's another look ahead episode. Hopefully, it's not too thick or too boring. There's a lot of information and a lot of work that takes place behind the scenes for building a house, like from material selection, supply chain, cost, and all that kind of stuff. So I'm going to show you the materials that we ended up choosing and why we chose them and why we ended up not using certain materials and whatnot. So let's begin with waterproofing. Why should you waterproof your house? If you're not aware of this, concrete is actually porous and it has the tendency to absorb water. So this water can eventually seep into your below grade basements and similar structures, and it can rot your materials inside the house. It can create an unhealthy environment such as mold and that kind of stuff. And even from the structure perspective, it can make its way to the rebar and actually corrode it and eventually degrade the performance and quality of your house. So that's why waterproofing is so important. So let's begin and let's talk some materials. Okay, so the system that we liked the most was Polywall Building Solutions waterproofing system for foundations. And we really liked it because it is easy to apply, or it appears to be easy to apply. And the reason I say that is because we actually didn't end up using the full system. But let me explain how it works, and then I'll explain the intricacies of it. So the first step in doing the waterproofing for the foundation would be to apply the blue barrier joint filler. And that is effectively this blue thing that you see here. Its purpose is to protect all cold joints. So for example, the gap or the space between the stem walls and the footing. And then also to protect any big holes that may be in the walls. And so that is additional protection for water. Then the next step would be to apply the Homestretch liquid waterproofing. And this is mostly the reason why we ended up liking this system. It is because this is actually like a liquid applied, so you can actually spray apply or roll it. It's very similar to painting, so you would need to apply 3 coats, so each coat takes a day to cure. And it seemed extraordinarily easy to apply, and that's why we ended up choosing this system. Finally, there is the Arroyo Drain board, and what this does is it gives water a path to exit and be diverted away from the foundation. As you know, water is the enemy of all houses. So effectively, water can seep into this drainage mat and then come down and then be expulsed onto the French drains and then diverted away from the water. From the house. All that said, we did not end up using the Homestretch liquid waterproofing, and the reason is cost. Okay, so we ended up using GCP's Bituthene 4000 system. This is a peel and stick application. This is kind of like a plastic HDPE that gets glued onto the stem walls. And the only reason we didn't end up using the liquid Homestretch from Polywall was cost. When we were about to purchase it, the price tag came in at around $18,000. And we thought this was a little bit crazy for us, at least in our case. And so we looked around and we ended up choosing Bituthene 4000 because we had seen other builders use this, and everybody seemed happy about it. I know Polywall also has a peel and stick application, but we just decided to go for this. In general, the system is the same. So let's go through their system. Okay, so the first part of their system is to apply the Bituthene primer. So what the Bituthene primer does is it captures the dust coming out of the green concrete. If you've been near green concrete, you will come to the realization that it is an infinite source of dust. It doesn't really matter how many times you clean it. Next time you come around, it's full of dust again. Who knows why, but anyway, the primer takes care of capturing all this dust and creates a nice surface for the Bituthene membrane to be sticked or applied to the wall. So then the next step is to apply the Bituthene liquid membrane. Notice this actually covers the same functionality as the Polywall Blue Barrier 2200. We ended up using Blueberry 2200 because that's what we were going to use for the full system, and we ended up using that for the cold joints between the stem wall and the footing. And we did also purchase a liquid membrane Bituthene mastic for the borders between the membrane and the concrete at the top of wall and at the footing. Notice here how there's all these different folds and cuts and all that kind of stuff. What I can tell you about that, and you will see that clearly in the next episode, is that it takes a lot of work to do this work. That's why we were thinking the homestretch waterproofing was the better solution. I think it might have been. We didn't use it because it takes a lot less work, but if you're maybe paying for a crew, you might come out even, let's say, if you were to use the other one, mostly because of speed of application. So I don't really want to dwell too much on this. All the instructions are on Polywall's website or GCP's, and they are all in the description below. This is just mostly what we are going to be using, and the reasoning why we ended up choosing one versus the other, $18,000 versus $6,500, so huge difference. So let's talk about French drains. So what is a French drain? The main purpose in life of a French drain is to divert water away from the foundation should it ever accumulate next to it. So this is a nice little detail provided to us by our soils engineer. So as you can see here, we have the stem wall, the footing. This is a slab and whatnot. And here's the French drain. So effectively, the requirement is to have a 10 mil plastic. So this is equivalent to the Bituthene 4000 that we are using, except we don't have it's not as short as this. We actually run it through the entire wall because we don't want any water penetration. Then we have the non-woven geotextile fabric. The non-woven geotextile fabric is a very important component. It's actually like a filter. It allows water in, but it doesn't allow dirt to go through. And that makes it such that the Schedule 40 PVC inside doesn't get clogged. It's not the same textile fabric that you purchase for gardening at Home Depot. Those can actually allow dirt to go through, and it can actually allow your pipe to get clogged. So it's very important to use non-woven geotextile fabric. Finally, here you have the crush rock. As part of the burrito, that could be the rice. The non-woven geotextile is the tortilla, and then your 4-inch Schedule 40 perforated pipe is the I guess your meat. Schedule 40 is important also because if you notice in this detail, we have all this dirt and there's a lot of weight, and so you need a pipe that can handle the weight, and that would be the Schedule 40 PVC pipe. It needs to be perforated because water accumulation could happen at any point in the house. So what you need to do is allow for water to rise its level and then eventually find its path onto the PVC pipe and then exit the house. Fortunately for us in the mountain, we can exit to daylight. Versus a lot of flat ground houses, they end up using a sump pump. So let's review the detail, our assembly detail. Here's our naked foundation. So then we've already discussed the waterproofing. The reason you see this blue is because, like I said, we were intending on using the liquid homestretch from Polywall, but we ended up replacing it for the Bituthene. We actually ended up covering the stem wall because we had the material and we didn't want any seepage of water onto the basement. So with the waterproofing in place, this blue thing, the next step is we will be applying exterior insulation, and that will be the next topic of this video. The reason I have not spoken about it yet is because most people don't actually apply exterior insulation, and we will talk about it in the next video. Once you have your exterior insulation, on top of it, you apply your drainage mat. So like I mentioned, there's like a small gap here on the drainage mat that allows water to go in. It's a dimple mat, and then this acts like a non-woven geotextile fabric, so water can drain all the way to the bottom and eventually find its way down to the French drain and to the pipes that divert water away from the house. And that's effectively the detail that you will see. Notice how we wrap the cross rock as if it was our burrito, and then we have the cross rock and the pipe. The pipe is very important to be perforated, and to be honest, we actually have 3 holes. Typically, we have there's a big debate about whether they should be down, up, or whatever. It's just better to have a few. The theory of the French drain is that water will rise, come in through the holes, and then eventually find its way out of the house. So this is the detail for our French drains. So now let's talk insulation. I have actually become a huge geek on insulation over the past years, mostly from the videos and building science and best practices of building that I've been seeing over time. And this is actually one of the main reasons why we decided to build our own house, because a lot of the houses that you see built either by production or in general, they get built the cheapest they may. Even the high-end houses, they don't get built to the standards that many houses can. A lot of people, they only seem to care about a nice kitchen and having it look nice and all that kind of stuff. But in reality, there's a lot more to a house than just a nice kitchen. And this is it. So because we are in Netherlands and we're in zone 7, so super cold, insulation is very important. So all building scientists, experts recommend putting exterior insulation and covering the entire envelope from foundation all the way to the roof. So let me show you. So this image is actually from a random house. I googled exterior insulation thermal bridge. And you can see the actual studs on the house. So what this means is you can see the heat exiting from the house onto the environment. So that means you're losing energy. So the concept of exterior insulation came from the fact that the best way to protect a house is to effectively put an entire coat or a jacket around it. So this is an analogy from Matt Reisinger that I've heard many times is imagine your ribs. So you imagine if you didn't have a coat, or if you had a coat with stripes or something. This is effectively what you would have. You would be cold in some places and warm in some others. So that's not the ideal scenario. The ideal scenario is to have continuous exterior insulation surrounding the entire envelope of the house. And that's effectively what we're going to do. And we're going to be following the best practices of building science. There are many types of insulation, for example, fiberglass, cellulose, mineral wool, open cell foam, closed cell foam. And what is its main purpose? Its main purpose is to prevent the transfer of heat. So the transfer of heat is rated by the R value. And effectively, the bigger the number, the less energy gets transferred in heat from one end to the other. Another nice advantage of insulation in general is that it makes for a more comfortable space to live in. So let me talk about these insulations very briefly. There's fiberglass. That's literally what it is, what it says. It can be difficult to apply and cause uncomfortable rashes and whatnot because it's literally glass. And so it can microscopically be cutting you, and that's what you would be feeling. So it requires special care. We will not be using fiberglass at all. Then there's the cellulose. It's typically blown in. It's kind of like a pillow kind of thing, full of feathers. It's similar, not the same, but it looks the same, similar. And then there's mineral wool, and mineral wool is actually our top choice for here in Colorado. It is not the highest rated R value, but it has properties that other insulations don't really have, and that is that it is extremely good against fire prevention. It can withstand maybe 5 to 10 times the amount of heat next to it compared to these other insulations. It is also very good against animals or insects, termites, since it's actually rock, they don't like to chew through it. The general process for mineral wool creation is they grab some kind of volcanic rock, they grind it somehow, and then they create the insulation. So it is an extraordinary product that you will see us use significantly. Then here we have also open cell foam, and a lot of ICF foundations that have embedded insulation. They use open cell. I personally don't love open cell because it's kind of like open cell is the insulation that's used for coffee cups. Let's say if you're in like an office or something. And the bigger problem with open cell is that it has a tendency to absorb water. And so over time, if it absorbs water, it loses its strength. And then finally, the top of the line, if you will, for our value is the closed cell insulation. It can be toxic as well when it is being applied. So you will see people wearing special suits. It is effectively plastic that's capturing air inside of it. So what allows it to have great insulation is that air inside of it. And just to briefly mention, and we will surely mention it again in the future, you should never compress insulation because it's the air that's helping the insulation prevent the heat transfer. And with that said, now let's talk some products. Okay, so let's talk Rockwool. As you may have noticed, I'm a huge fan of Rockwool. We are actually not sponsored in any way or form, but by living here in Colorado and particularly in the mountains, fire is a tremendous concern. So if there ever was to be a fire, we want to give this house the best chance it has to surviving. And I think for that, one of the components would be Rockwool. So check out this. This is their front page, and they have blow torches onto the Rockwool, and it is perfectly nice and safe inside. As a builder, we are part of their Builder Elite program. And so what that means is they give you a discount. And but one thing that we've gotten from them is we gave them the floor plans and the zone of the house. And then they came back with an analysis of the entire house and our assemblies for our different walls and how much we should be using at different levels. And effectively what they came back with is they gave me a recommendation to put 4 inches worth of Rockwool insulation around the entire envelope of the house. And so that involves the foundation. So this is their analysis. It's actually a 9-page document, and they go through the different assemblies and whatnot and recommendations. They not only look out for temperature, but they also look out for the very important condensation lines. So typically in every zone in the US, you will have a time where it is likely that you will condensate water on the walls, and condensation is really bad because it can create mold on the surfaces. The other day here actually in Colorado, I was talking to a guy and I told him this wall could potentially create condensation in the cold, and he was always saying, well, Colorado is so super dry that it would never happen. Well, condensation is not a factor of dryness alone. It is a factor of delta in temperature. So if you're really warm inside and you're really cold outside, you will create condensation because typically a home will have an acceptable relative humidity of 30 to 40% here in Colorado at a temperature of 70 F. Versus being in the outside where it's like super cold, close to like 0 Fahrenheit. And by having that change in temperature, you are creating the possibility for condensation to be created. So here, Rockwool gave me this analysis, and they manipulated my assembly up to the point where the condensation and mold growth was kept to a minimum. And so that's how they came up to the recommendation of 4-inch for our envelope. So 4-inch on Rockwool is equivalent to 4.6 R. So that's per inch, and 4.6 is about 18.4 R value. So now that we have the analysis, then the selected product for the exterior envelope of the house will be Comfort Board 80 from Rockwool. It is just a little bit harder insulation that can withstand the exterior environment a little bit better. We did run into a hiccup with Comfort Board 80, actually not Comfort Board 80, Rockwool in general, and that was when I called them to order the panels. They said that they didn't have any available for 6 months. And so that was a tremendously huge problem. As you know, 2021 has been a very difficult year for the supply chain, not only insulation. And so because of this, we started thinking, okay, so what can we do in the meantime, or what other product could we use? So we started thinking, and we said, okay, well, our insulation is going to be, at least this first phase is going to be for the foundation. And the foundation is going to be mostly below grade. And so what that means is, with fire being our top concern and being below grade, it means that it's not going to burn because it's going to be buried. So at most, maybe 6 inches will be exposed, and we will be covering this with metal flashing anyway. So we decided to use Owens Corning XPS insulation, the top of the line when it comes to R value. And so yeah, that's what we decided to do. An interesting story about the XPS insulation. We looked for it here in Colorado, and each panel was 4-inch was $130. And we actually found it way cheaper in Wyoming for $80, the same insulation. So we ended up taking a nice little trip to Wyoming to purchase these products. Another actually story related to cost is the Bituthene I discussed for waterproofing and the geotextile. I also looked for it here in Colorado, the Bituthene, and each roll was like $400 per roll. And then I found it in North Carolina for $230. So guess what we did? We ordered it online and we shipped it over to Colorado. So we've been doing a lot of that kind of stuff to attempt to save money. So now let's talk a little bit of XPS insulation. Okay, so when I started my research, actually we were thinking of using XPS until eventually fire became a huge top priority. So that's when we ended up switching to Rockwool. But in my initial research, when it came to insulation types between polyiso, open cell, closed cell, blah, blah, XPS ended up being the top performer and our first choice. And like I said, since we're going to be doing this below grade, this will end up working out great. One interesting characteristic of this XPS insulation is that as temperature goes down, it actually increases its R value. And because we are in zone 7 and we are protecting our heat from the cold, it is actually benefiting us when it gets into those, when it needs to get to work, I guess. Rockwool did mention that XPS lose its R value over time. It can lose up to 10% in 10 years when it settles. And that's perfectly fine because even after losing 10% of its performance in R value, it will continue to have a better R value than Rockwool. So yeah, because we're below grade, it's going to be fine. And so let me talk a little bit about the installation process. So you will definitely need a joint seal R on top of your Foamular XPS 25. The 25 actually comes from 25 pounds per square inch PSI. And that's typically good enough for any residential house. By the way, we will be using XPS below the slab as well. So this is our assembly. Actually, the way this is shown, it is actually incorrect because Owens Corning recommends to install the panels horizontally. So once you install the panels horizontally, you apply the joint seal R. And the way you install the panels is by gluing them to the substrate. Since we've been doing this in the winter, we've been having difficulty finding glues that can actually work in the cold, like below -4°C. So I highly recommend using mechanical fasteners. And the mechanical fasteners we've been using are these Rodent House plastic grip. They actually thermally broken. So what you end up needing to do is drill a hole in the concrete, and then with a mallet you end up pushing this onto the walls. Another reason for using this, even if it's not cold, is the foundation walls are not perfectly flat like they are here on Blender. They are typically full of bumps and whatnot, so even if you use glue, it may end up being glued to one side but not the other. So when you use the Rodent House fasteners, you take care of all those problems, and you end up with a very nice performance. So that is it, I guess. Hopefully it was informational for you. Like I said, a lot of these brands, we're not sponsored in any way or form, but we're definitely going to use them. We highly recommend all of them. I also did not want to go into the super details of installation because they have very nice documentation, and I recommend you read them. We're just kind of giving you all our experiences from the things we're having to do, from cost, supply chain, the different decisions that we're having to make due to different circumstances. So yeah, if you have any questions and you're still here, and hopefully it wasn't too boring, see you in the next one.